Hi everyone, in today's lesson we're going to talk more about motion of a line. Today our goal is going to be talking about the difference between displacement and distance. Displacement is defined as the length of the shortest path from start to finish, where distance is the length that the particle travels in total. Here are directions on how to calculate. I will go through that as we do a couple of problems, but I want to just talk a little bit about the difference between these two things. So say we have a particle that is moving on a horizontal line. And let's just say here is where I start the particle. We'll say this happens at time equals 0. And let's just say the particle moves 10 units to the right. And we'll say this is at time equals, 5 seconds. And then it goes back. And let's just say this is at 10 seconds. And then it goes forward one last time to, time equals 12 seconds. So if I were to calculate the distance would be how much it traveled. So let's just say from time equals 0 to time equals 5, I went 10 units. Then from time equals 5 to time equals 10 seconds, I went 5 units. And then from time equals 10 to time equals 12, I went 11 units. So if I wanted to calculate the distance, I would add up all of those pieces. So the distance would be 10 plus 5 plus 11. So that would be 26. That would be my distance. But my displacement would be the length of the shortest path from start to finish line. So the displacement would really be from the beginning here to the end here. So what would that distance be? Well, let's try to calculate it. So from here to here, I went 10, right? But I went back 5, and then I went forward 11. So really this 5 that I went back doesn't really, not that it doesn't count, but we have to account that I went backwards again. So I don't need to really add that. So if I went 10 this way, then 5 back, I'm really only, I would say, right here in the middle at 5, right? And then if I'm at 5, then I go 11, right? So if this is your 11, then I really only went 5 plus 11, which is 16. So to make more sense, I went 0 to here is 10, and then I went back 5, so I'm at 5 now, and then go forward 11, my total displacement would be 16. So really, how much did I go from start to finish? And that's the idea of what we're going to calculate today. So let's do an example together. So the first example says a particle moves along a horizontal line according to this function, where time is greater than 0. Time is measured in seconds and S of t is measured in meters. Find the displacement of the particle during the first 5 seconds. So all you have to do for displacement is, the formula is S of b minus S of a, where A and B are the endpoints of the interval. So the first 5 seconds means 0 to 5. So 0 is my A value and 5 is my B value. So S of 5 minus S of 0 will calculate our displacement. So if you notice, S is my original function. So go ahead and plug 5 into my original function, then plug 0, and then subtract them. And then hit resume when you're ready for the answer. Okay, so for 5, S of 5, you should have gotten 3. And for 0, you should have gotten 8. So 3 minus 8 is negative 5. So if you have a displacement of negative 5, that just means the particle landed, so let's actually write this down. The particle ended 5 units to the left of the starting point. Okay? If the displacement was positive, then the particle would have ended 5 units to the right of where it started. And I'm going to show you visually what that means once we draw the picture. So that'll happen in part B. So part B now is asking us to find the total distance that was traveled by this particle during the first 5 seconds. So the interval is still the same, still 5 seconds. So there's a couple of things that we need to find for taking care of distance. So the first thing that we need to do is find where the particle changes direction. And remember, where it changes direction is where v of t is equal to 0. So first, we need to find the velocity function. So if we remember the original function s of t, we'll start with that and take the derivative to find v of t. So the derivative of s of t, using the power rule, is 6t squared minus 30t plus 24. So all I did was use the power rule here and take the derivative to find the velocity. And now I'm going to set that velocity equal to 0, factor, and solve. It looks like I can divide all three pieces by 6, so I'm going to do that. And factor by add multiply. So t minus 1 and t minus 4. And if I set each piece equal to 0, I get t is equal to 1 and t is equal to 4. 6 equaling 0 we can reject. So we know that the particle will change direction at 1 second and at 4 seconds. So that's the first thing that we have to do, figure that out. The second thing that we're going to have to do is make a chart of these values. Okay, so step 2, make a chart with the s of t values. So t and then s of t. So it's like x and y. All right. The first value is going to be the first point of the interval. So the interval here is the first 5 seconds. So the first value is 0, and the last value is 5. And then in between, we need to put where it changes direction, which is at 1 and 4. So in your chart, always, the first value here is A, the endpoint of the interval. The last value is B, the endpoint of the interval. And in the middle, this is where it changes direction. And it's important that we find this information so that we know how many spaces it went right and how many spaces it went left. So what I'd actually like you guys to do right now is go to the y equals in your calculator, and I'd like you to put the s of t function, this green function up here, into your y equals. And I want you to tell me the corresponding y values when x is 0, 1, 4, and 5. All right, so go ahead and go to your y equals and put this in there and tell me those corresponding y values and hit resume when you're ready for the answers. Okay, so for 0, you should have gotten 8. For 1, you should have gotten 19. For 4, you should have gotten -8. And for 5, you should have gotten 3. Now, the values that you just found, the 8, the 19, the -8, and 3, these are the positions on the horizontal line. Okay, so let's draw our picture now. All right, so we're going to put our positions on a horizontal line like so. So we've got these numbers, 8, 19, -8, and 3. So let's put them on the number line according to where they belong. So -8 is the smallest, so I'll put that here. +8 and +19. So I don't know, +8 would go here, maybe +19 is a little bit bigger, that'll go there. And then 3 would go somewhere here. Your picture doesn't have to be perfect. You know, if you want to make it as close to scale as possible, that's fine. So now what we're going to do is we're going to draw our particle movement. So it starts at time equals 0 at 8. So we're starting at 8. So you could put your first dot here because that's the position on the horizontal line. So we're starting with 8. We'll call this time equals 0. Then I travel to 19. So I go to the right to 19, and that's at time equals 1. Then I go back to negative 8 at time equals 4, and then I end at 3 for time equals 5. So that is your particle movement. We go right, we go left, and then we go a little bit right. So we said displacement, let's just look at this. Displacement is negative 5. The particle will end 5 units to the left of where it started. Well, it started at time equals 0 here at 8, and it ended at time equals 5 at 3. So what's the difference between 8 and 3? Nothing other than 5, and the particle ended left of where it started. Okay? So it's really important that we follow these 2 steps. We make sure our chart has all of the pieces, and then we can draw our picture nice and easy. All right, why don't you guys try a problem entirely on your own now? And then hit resume when you're ready for the answers. Okay, here is the work for part A. All right, so a couple of things to look out for. When you're doing S of B minus S of A in this problem, please make sure you recognize this double negative. So you should have gotten 59 minus negative 1 for S of B, which, by the way, S of B was S of 6, and S of A was S of 0. So at 0 and 6, that's what it means to be the first 6 seconds. And I know it didn't ask you to explain, but it's important that you know that since it's positive, the particle actually ended 60 units to the right of where it began. Okay, here are the answers to the second part. Okay, so to find the total distance, we first have to find where the velocity is equal to 0. So first I found the velocity by taking the derivative of s of t. Then I set it equal to 0. I factored out a 2, and then I factored the trinomial. I used guess and test, and I got 11 thirds and 1. So this is where we're changing direction. So I remembered from the last problem. So A is 0 is my first term. B is my second or last term, rather, which is 6 seconds. And in the middle is where it's changing direction, which is 1 and 11 over 3. 1 is smaller than 11 thirds, so I put that first. Then I went to the y equals in my calculator, and I put this function into the y equals. And I copied down the table of values for 0, 1, and 6. But 11 thirds is actually not on the calculator. So in order to get this value right here, what you actually have to do is plug in 11 over 3 every time you see an x. So you're not going to be able to get that from the y equals. So you'll have to type in 2 times 11 over 3 cubed minus 14 times 11 over 3 squared plus 22 times 11 over 3 minus 1. So take a minute and pause the video, type this into the calculator, and see if you get this value. And then once you're ready and you feel comfortable, you can hit resume and we'll move on to the graph. Okay, so the picture now to find the distance. So here is my picture, and remember I'm putting my values here, these 4 values, on my horizontal line. So these are the positions on horizontal line. So I'm going to put 59, which is my highest, probably down here to the right. Then I'll put negative 9.96, which is the smallest. And then I'll somewhere put a negative 1 and a positive 9. Okay, again, picture doesn't have to be perfect. So now we're going to start. We're going to put the first position to be negative 1, and that's at time equals 0. So we're going to go ahead at negative 1 and put a little dot and say this is at time equals 0. Check. Then we're going to go to 9 and put a second dot, and that's at time equals 1. So we move to the right. Then my third dot is negative 9.96, and that's at time equals 11 over 3. So I went right, then I'm going to go to the left. And then the last one is back all the way over here at time equals 6 for 59. So I'm going all the way back to the right. So if I want to calculate the distance this time, I'm going to have to add up all of the pieces. So from negative 1 to 9, how many spaces did I go? Well, I mean, -1 to 0, right? If 0 were here, there would be 1 space and then 9 more, so that's 10. So we can go ahead and say from here to here is 10, right? And then how about from +9 to -996? Well, I know that if 0 were here, maybe I'll even put 0 there, that'll help you add it. So if this is 0, right, from 0 to 9 is 9 spaces. And then from 0 to -9.96 is another 9 spaces. So I just have to add this and this together, which would give me positive 18.96, right? And then last but not least, I'm going from -9.96 to +59. Well, go to 0 first. From here to here is 9.96, and then from here to here is 59. So add 59 plus 9.96. So 59 plus 10 is 69, so 68.96. So that would be that distance. So to find the total distance here, I'm going to have to add them together. So 68.96, 18.96, and 10. So by adding those, this is 12, 18, that would be 19, 16, 17, 6, 7, 8, 9. So your total distance would be 97.92. All right, I know this one wasn't the easiest, so if you have any questions, now's the time to jot them down and make sure you ask us in class tomorrow. All right, have a good night.